Hi everyone. In this video I'm going to show you how to find the integral of a exponential function. So you can see we have three rules. The first one is about base a. So that means that we can use that formula or that integral when you have an integral like this, like the integral of 7 to the 2x times the x, because the base is a real number different from e, which is this one. So whenever you have base e, you're going to use this rule, this one. Another example for the first one could be the integral of 2 to the x squared times the x. In those cases, these two cases, you're going to use this rule because you have a base different from e. But if you have base e, like this one, then you're going to have you're going to use this rule. And the very last one, this one that we have here, number 8, is only for e to the x. It can be used only in this case. It doesn't work for e to the 2x. If you have an integral like e to the 2x, then the rule you have to use would be this one. Or if you have the integral of e to the cosine of x times sine of x times differential of x, you're going to have to use this one. If you have the integral of e to the 5x times the x, in that case, you're going to have to use this one. So you're going to use the very last one, number 8, when you have the integral of e to the x. Now let's try the first example. The first thing that I'm going to do is I'm going to rewrite this as e to the negative x times the x. Now, since we have negative x as the exponent, we're going to make u equals negative x. And then its differential will be negative 1 times dx. Since we don't have negative dx, we're going to multiply by negative 1, as we have done this for some other exercises. So we would have negative 1 times differential of u. Now we're ready to do the substitution, so I'm going to do the integral of e to the u times negative 1 times differential of u. As you know, negative 1 is the constant, and then the integral of e to the u times differential of u, it's pretty simple because equals e to the u plus the constant. Now we have to substitute the value of u, and we have negative e to the negative x plus the constant. Second exercise. For this one, I'm going to give you a tip. Whenever you have a quotient, it's a good idea to make u the denominator, because most of the cases you're going to obtain its differential in the numerator. So check this out. If I make u equals 1 plus 5 e to the x, its differential will be 5 e to the x times differential of x. We don't have here 5 times the x, but that's not a problem. You know that. You have done this. So all we have to do is to divide by 5 both sides, and then we're ready to do the substitution. So the substitution would be the integral of u to the negative 1 times 1/5 times differential of u, because e to the x times the x equals 1/5 differential of u. And then 1/5 is a constant, the integral of u to the negative 1 times differential of u. You know, and you have to remember that this is an important integral because this is the exception to the integral of u to the n. Remember that we have a negative 1 as an exponent. The integral equals the natural logarithm of u plus the constant. So we have 1/5 times natural logarithm of u, which equals 1 plus 5 e to the x, absolute value because of the domain of a logarithmic function plus a constant. If you want to check if this is correct, all you have to do is to obtain the derivative. In order to make this integral pretty clear for you, I'm going to rewrite it before anything. So I'm going to write 4e to the natural logarithm of x times 1 over x times dx. Why am I doing this? Because if you look at this, we have this exponent, which is natural logarithm of x, and its derivative equals 1 over x. So it's a good idea to make u natural logarithm of x, which is the exponent of the letter e. So its differential will be 1 over x times differential of x. And then we're ready to do the substitution. We can write this as 4 times the integral of e to the u times differential of u, because 1 over x times dx equals differential of u. And then, as you remember from the first at the beginning of the video, you have the rules. So the integral of e to the u, it's simple, e to the u plus the constant. And then we're going to substitute u, which is natural logarithm of x plus the constant. Again, if you want to make sure that we're doing right, just try the derivative. As I did in the previous exercise, I'm going to rewrite this integral as the integral of e to the x squared times 14x times dx, because I want you to see that it's a good choice to make u equals the exponent, which is x squared, because its differential equals to x. So if we make u equals x squared, then its differential would be 2x times differential of x. As you can see here, we have 14x, so all we have to do is to multiply by 7 both sides of this equation. So if we multiply that, we're going to obtain 14x times the x equals 7 times the u. So now we're ready for the substitution. So this is the integral of e to the u times 7 du. 7 is a constant, the integral of e to the u times differential of u. It's a pretty easy rule because you obtain the same function, e to the u plus the constant, and then all you have to do is to substitute u for x squared plus the constant, and you're done. As you can see, the integral of the exponential functions is pretty easy. Most of the times u is going to be equal to the exponent, but I said most of the times you have to be aware of whatever you have here in the integral. Okay, so it was a pleasure. Hope you like it, and I hope you believe this is a better video. Thank you, guys.